it started.
Okay, so welcome back to physics. It's good to have you. We were running a bit of a tight schedule, so last time we did not finish what we were supposed to finish this time. So this time we will try to pick up the pace, but if it doesn't work, then we'll just have to deal with it. But it shouldn't be that difficult. Okay, so last time we were just ending off on this question. All right, so in this question, right, we talked about a person, and this person travels 5 meters north in the first 10 seconds. He then stops, like, imagine he instantly turns around. Like, he doesn't have, there's no, like, time that he can, like, adjust his position. Just imagine that he just turns around right away, which it's unrealistic, but you have to, these type of questions are occurring in Physics 10 because they're just really simple. Okay, so in the second part of his travel, he travels 6 meters south in 18 seconds. And then the third part of the travel, he travels 3 meters north in 1 second. So this says speed and time are fluctuating. So given this information, right, we can solve for things like the distance, the displacement, the average velocity, the average speed, and the instantaneous speed, which means at a certain point in his travel, I can ask for the speed and you should be able to give it to me. So in these cases, since he's traveling at the same rate for each three sections of the journey, it's a really simple formula. But if he was running and he was going fast and slow, then it would be difficult to tell the instantaneous speed. So you would need a graph or you would need some sort of formula. So so in here, we can ask for instantaneous speed and velocity because we have simple formulas for these, and he's traveling in uniform motion for all three of the sections. Okay, so let's draw a visual of what is happening here. I want to use green. So he's over here, and he's going to travel 5 meters north. Okay, so first we always need to define positive and negative directions. So northeast, southwest. I'm gonna write this is positive and this is negative. There's no east, so yeah, this is fine. Okay, so he's gonna travel 5 meters up. So this is gonna be 5 meters up north in 10 seconds. And then he's gonna travel 6 meters south. So he travels 6 meters south. So this is five, remember? So that means he travels one more meter down from his original point. Uh, because five it goes down five and goes down another one. Okay, and then from this point, he travels 3 meters north again. So he travels 1 meter up to where he originally was, right? And then to complete the remaining 3 meters, he goes up 2 meters again. So 2 meters. So just based on this diagram, could you please tell me what his final displacement is, where he finally ended up? Oh, yeah, type it in the chat or unmute your mic. So like his displacement means a straight line from where you started to where you end. So in this case, where did he what is his displacement? Like where did he end up from his original position? Okay, wait.
We'll restate the question. Why not? So he went 5 meters north, right? Tony, just confirm that I got this
Yeah,
right.
yeah.
And then he went six meters south, and then he went another, and then he went back 3 meters north. What is his this displacement from his starting place?
Yeah, that is the question. Okay, so I'm gonna pretend Rachel is a student, but also
Oh,
just like
oh yeah. All right.
unmute just unmute your mic. Like it's only a three-person conversation. So just unmute your mic the whole time because like this typing thing is not working too well. Okay, yeah. So just unmute your mic when I ask the question, okay? Okay, so Rachel, what is his final displacement? Is the person's final displacement
Yeah.
if he undergoes this motion?
Since we're gonna identify north as positive, so he went 5 meters north, and then he went 6 meters south. So 5 - 6, -1, and then he went another 3 meters back north. So -1 plus 3 is 2. So his total displacement is 2 meters north.
Okay, very good. So I was gonna say I was gonna show how to do this like
Oh,
with like, but it's fine, it's fine. But basically, what Rachel did was, um, she defined the directions, positive and negative. So usually, when there's a type of question where you need to add up a bunch of vectors, you add them up, but you need to add them up with a sign. So, for example, 5 meters north we define as positive, so it's just 5 meters. 6 meters south we define as negative, so -6 meters. And then we need to add up 3 meters north, which is defined as positive. So after adding all of this up, right, you will get a number that is 2 meters, right? And since this number is positive, right, this must mean that she is 2 meters north, because that is how we define the question, where north is positive and south negative. Does that make sense?
Yeah.
Okay. So now we're going to calculate this person's distance. Okay. So reminder that distance is how far something has traveled in total. Okay. So could you tell me the displacement of this individual?
he meant the distance.
Oh, yeah, the
Oh, okay.
distance. Sorry. So distance is oh, sorry. Yeah. Do you have an answer for the distance?
Uh, so the distance he traveled, right?
Yeah. So the distance is how
14 meters. 14.
5 plus 6 plus 3. Yeah, it is 14 meters. So it's just 5 meters plus 6 meters plus 3 meters equals 14 meters. Okay, so now we have that part down. Okay, so these things are his total distance and displacement, because right, it's total. If I could ask you for the displacement and distance for one part of his journey, but we are doing the whole thing. So remember that, just a reminder that this is total. These are both total distances and total displacements. Okay, so now let's move on to the next part of our question. So knowing that this is the total distance and knowing that this is the total displacement, how would you find his average velocity and his average speed? How do you think we would go about finding that? If a reminder that the formula of those two is that average speed is total distance over total time, and average velocity is total displacement over total time. So using this formula, how do you think we should go about finding these two values?
So first of all, the total distance was 14 meters.
Yeah.
So we do 14 meters divided by divided by 19 seconds.
Okay,
wait,
so
no, just kidding. 29 seconds.
Yeah, 29 seconds. Yeah, so you total time, you just add up all the seconds. Okay, so now doing this, you can find the average speed. We're doing speed right now. So what would his average speed be to the correct significant digit?
It would be
Okay, wait, hold on. For these, we didn't do them in correct significant digits. So this is 14. So this is not correct significant digits. So just give it to me. Yeah. Like, give it to me in the correct significant
Wait, sorry,
digits.
what?
Okay, give me the answer in the correct significant digits, but just realize that the distance that we solve for, we stated it as in the wrong significant digits, but like it's wrong, but just recognize that it's wrong. Like, but we're gonna from now this point on, we're gonna do correct significant digits. So, what would the answer be for the average speed?
0.4.
Okay, so when I put 14 over 29 in the calculator, I got 0.48, right? Meters per second. Okay, so rounding 8 to 4 rounds up, so it would be 0.5 meters per second, not 0.4. So any number above 5 rounds up the number. Does that make sense?
Okay.
So this is the average speed. Okay. And to one significant digit because these are 1. Okay, so now let's solve for the the average velocity. So what would we put on the numerator and what would we put on the denominator? Like what would we put on top, what would we put on the bottom? So this is the formula.
So for velocity?
Yeah, average velocity of the entire of the person's entire travel. Yeah, so this is the formula. So what would we put into here?
So the total displacement is 2 meters.
2 meters north, so positive. And what's the total time?
The total time is 29 seconds.
Yeah, okay, cool. Okay, so now we just enter these two numbers in the calculator. And give me the answer in one significant digit with units and the direction because it is a vector quantity.
Uh, 0.06 north.
Okay, so once again, you have a rounding error. So this is what you get in your calculator, roughly what you get in your calculator, right?
Yeah.
Okay, and remember it's to the north. So any number that is 5 or above rounds the previous number up. Okay. So it's like 15.6, right? If we want to round it to the nearest whole number, this is bigger than 5. So this will round this up. So 15.6 turns into 16. So just like here, right? If this is happening and you want to round it to one number, right? 8 is bigger than 5. So this 8 will round the 6 up by 1, which will turn it into 7. So 0.07 meters per second north is its average velocity. Does that make sense? Like just rounding in general? Like, do you know how to round things?
Yeah.
Okay. All right. So what would this number round to? What would this number round to? To the nearest 2 decimal places. What would this number round to?
Uh, 0.0. Wait, so it's to the nearest decimal?
2 decimal places.
2 decimal, okay. 0. 0.05.
Yeah, because the 3 rounds this rounds. I mean, no, the 3 does not round it up, so it just stays like this. Yeah, so nothing can round down, but it can only round up or stay the same, right? But in this case, right, never be tempted to round multiple things. So you see a 6 behind the 3, so you want to round this to a 4. That we can't do that. Okay, you only round what is directly behind it. Okay? So that's the only thing that you round. Okay? Only round
Alright.
things that are directly behind. All right. So now we have reached to a point in the question where we are going to find the speed for the average speed. Well, yeah. So the average speed for all three of the trials and the average and the velocity for all three of the trials. So this work I believe that you can do by yourself. So we'll let you try it on your own, and you get stuck, like just tell me. We'll give you like 2 minutes to do it. So remember the formula for speed. Oh no, okay. The formula for speed or velocity is distance or displacement over time. So using this formula, you should be able to get what we need for each one. The average speed and velocity for each of the three trials. So I guess just try it on your own for now. Yeah. Okay, Rachel, can you also be a student right now?
Yes. What is
Okay.
the question?
If you are due to do the same problem as Angela, and whoever gets an answer first, just say it. Yeah.
Bro,
No, it's just like do the same work
yeah.
as her, right? And if you've reached a conclusion, just feel free to say it.
Tony, check chat.
Chat.
Private.
Oh, okay. Oh, so the question was just find the average speed and average velocity for each section individually.
Each section, so like part 1, 2, and 3.
Yeah. So this section has this dividend information and this dividend information, and this section has this and that. Yeah.
All right.
And it should only be one calculation, but we'll see. Okay.
For each section, I need to grab my calculator. My phone works.
Okay, Angela, did you get any answers for this? Hello? Did you get anything? What?
Tony's so aggressive.
How's that aggressive? Okay, did you get anything yet for this
No.
question? No? Okay, so what part are you stuck on in this question?
No, it's just that I can't actually hear the question.
You can't hear. Okay, so is there something wrong with the audio? Like, what do you mean you can't hear the question?
Like, no, it's just I can't really hear it clearly.
Really? Is the audio okay out for you, or like just don't know? Don't.
Just like what's wrong?
It's just that sometimes it sounds a bit muffled, so I'm not really sure.
Oh.
Okay, so please be like clear when we are.
No, maybe it's an issue with her headphones or what she's using.
Yeah. What are you using to listen?
Yeah, I'll pause the recording. They don't need to hear all of this.
Yeah. So Rachel, what do you get for this question?
Wait, for speed and velocity? Okay, I need to ask you if this is meant to be a trick question because speed and velocity for each section is going to be the same, right? for the sections individually.
Okay. Well, the trick, well, the quote unquote trick was that I wanted you to recognize that the magnitude was going to be the same, but
Oh,
the direction was going to be like one has a direction and one doesn't.
oh
But
yeah,
essentially they're the
actually,
same.
yeah.
Yeah. So the quote unquote trick was just that uh speed and velocity can have the same magnitude, but velocity you always need to watch out for the sign. So for the positive or negative, okay? Does that make sense? It's a nice piano. Hey
Wait,
Angela, when I'm like
Yeah.
saying does that make sense? Like I'm asking you, like you're
Yeah.
the student. Okay, does that make sense?
Yeah.
Okay, so if we want to run through this really quickly, 5 over 10, 1/2, so 0
Hello?
point. Hello? Okay, I think that piano is like,
Sorry, I'm just gonna move a place.
okay. Why is the piano getting louder and louder when she moves?
Okay.
All right, so we run down this really quickly for section 1, 5 over 10, that's 1/2, so 5 meters per second is the speed. 0.5 meters per second is speed, the direction is north. This sits over 18, so that's 0.3. If we round it, it'll be 0.33. So if we round it, it'll be 0.3 meters per second. But this is going south. And then finally, for this is 3 over 1. So that means it's 3 meters per second. And it is positive. So we are going north. All right. So that was, this is basically like the hardest type of uniform motion question you can get. Well, I wouldn't say this is the hardest because there's a harder one. We were gonna. I wanted to try it, but we'll see. We'll see about that because that one would take a while to explain. But fine. Let's just move on to a new concept. Okay. So moving on from uniform motion type things, we are going to look at acceleration. Okay. So I think you've heard the word acceleration before. But it's a little bit challenging. The first time I heard it, it was a little bit challenging to explain. So the definition of acceleration is that it is the rate of the change of velocity. So that means in simpler terms, it's how much the velocity, not the speed, okay? How much the velocity changes every second. So it's every so it either increases or it decreases. But its unit is meters per second. Oh, are you writing this? Are you gonna write it down? Because I think I scrolled too fast.
Oh no, I'm just not writing everything down. So
Okay, but basically, yeah, it's just just know that it's a change of velocity per second. So its unit is meters per second squared. Okay, so this might seem really odd, but what it really means is that it is per speed over second. So remember, in speed, right? We saw that it was meters. It was per unit of distance over per unit of time. So for acceleration, it's just like per unit of velocity over per unit of time, right? So we simplify this out further. It'll be meters per second times 1 over set s, fractions, reciprocal. So it'll be meters per second. Okay. Do you understand where the meters per second comes from now?
okay.
Okay. So I don't know. Because when I first saw that, I was really confused. Why like you could square a second? Like how can you take something in time and just magically square it out of nowhere? Okay. Okay, so this formula is written really poorly because we don't have vector arrows on our thing. But the formula for acceleration, okay, is acceleration with a vector equals. Okay, I wanna zoom up closely so I can write it better. Is the final velocity, which is dictated by vector v with a little f subscript for final, subtracted my initial velocity, which is a V, a little arrow with an I on it, so initial, all over t, which is the time. Okay? So the time could also be written as, if you want to, right? The time final over the time initial, but this is like mostly pointless, but it could be useful in some cases. But just you don't need to remember this. But if you get stuck, like if there's a graph, like to be honest, I don't
Wait,
understand
Penny,
this
Penny,
section.
Penny. I'll
Huh?
I'll take care of the chat. It's okay. I'll let you. You don't have to look at chat. So since it's hard to do so while teaching, right? So I'll take care of anything in chat.
Okay, but you said you don't understand it.
What? No, I'm saying I didn't understand why the heck
Yeah.
accelerations units second squared. Second squared still doesn't make sense,
Oh,
and that's
okay. Well,
okay. No, I know how to get there. It's just second squared is not like
yeah, it doesn't make sense.
yeah.
But a lot of things, like unit-wise, a lot of things don't make sense. Like if you think about it, a lot of things just don't like all the constants and stuff like in science, like those don't make a lot of sense either because they're really weird units. But I guess acceleration is somewhat understandable if you know what you're talking about.
Mhm.
Okay, but okay, so anyways,
So then you don't need to check chat. I'll take care of anything like that.
okay, no, I can probably see it, but I'll check like once in a while.
Okay.
Okay, anyways, so now the question is, does this formula look familiar? So do you know what a slope is?
Uh,
Change
no,
of y over change of x. You know that math thing on graphs.
Yeah.
no.
No.
Okay. Uh, okay. Well, okay, this will take up some time. Okay. So the slope, which is dictated by m, is a change of y over change of x. So in math, right? It's usually so if there's a line, right, passing through the x and y axis, right, we can find out how steep the line is, right, by determining for how many y's, right, there are per x. So that also means the change of y over the change of x. Okay, so the formula for this is if you take any point here and any point here, or just two random points on the line, right? And this is if this is point one, we'll call this x1, y1. If this is point two, we'll call it x2, y2. Then the formula will be y2 over y1 minus x2 over x1. So the coordinates of one point subtracted by another in both of the rows will get you the slope, which is the rate of change, right? So as an example, if one of our points is 2, 5, then another of our points, and this is an example, so negative, the other point, I'll say it's -1, -1, -1. Okay, so using the new formula that is presented here, where you take the coordinates of one point subtracted the y's of one coordinate subtracted by the other, and then you take the x of the same coordinate subtracted by the other, what would the slope of this line be? So given all this information, what would the slope be? It's just you just plug in the numbers and solve for it. Okay, so um are you gonna try it out yourself, or do you want me to just like say what it is?
I will. Um,
Okay,
I
like
will like.
usually when I say things like what is it or like try it out, like that means try it out. Like, if that
Can you
makes
see what it is?
so you okay. So I will say what it is for now, but like I always try and ask examples. So just bear with me when I ask an example. Okay. All right. So y2 we see here is -1, right? And we subtracted by the y1 here, so that would be 5 minus 5. X2 that we see here is also -1, which is then subtracted by the x1 here, which is 2, so subtracted 2. So notice how these are all 1 point, are like the 2 point, and this is the 1 point, right? You have to put it in this you have to put it in this order where it's 1 point minus the other, okay? Usually when I say okay, like just try and say okay back, because I'm like a very verbal person. Like this is how I talk in person. If I'm always explaining something, like if it's dead silence, like I just don't know how to function. So does that make sense?
Yeah.
Okay, so this will simple -6 divided by -3 will simplify to 2. This is the rate of change between here and here. So that means every time the x goes over by 1, the y goes up by 2. Okay? This is essentially what this means. And this pattern will create a line like this. And if a slope was negative, right, every time it goes by 1, the y would go down by -2. So it would form something like this. So now you know what a positive slope looks like and what a negative slope looks like. Okay?
All right.
All right. That. Okay. So now there is this formula, which is acceleration. So we're going to try a problem with this formula. Okay? So the problem is, I'm going to type it out. So it's an object at rest accelerates to a velocity of 15 meters per second north. Oh no, where's the bracket? In 3 seconds. All right, so with this question, you have all the information you need to find the acceleration. Oh, I always need to type what the question is. What? Oh, shoot. What is the acceleration of the object? Okay, so given this information and given this formula, it is pretty easy to solve it, but there are some terms you might be unfamiliar with. So for example, an object at rest. What do you think at rest means?
Not moving.
Yeah, an object is not moving. So if it's not moving, it has no speed. So what would the speed be?
0.
Yeah, 0. Okay, good job. So 0 meters per second is the speed. Okay, so this is the first speed. So using this formula, what piece of information does this give you? So we have final velocity and initial velocity. What would this velocity be?
The initial velocity?
Yeah, so it would be the initial velocity. So initial means start. Okay. Why is okay? Something's really weird with my computer. Okay, so this would be VI. All right. So now let's start filling in the information. What would the final velocity be?
It would be 15 meter per second.
Yeah. What direction?
North.
Yeah, north. Okay. So do you want to set north as positive or negative?
Positive.
Positive. Okay. So always draw a little thing like this. North, east, south, west. This is positive. Okay. Good. Okay. So north is positive. Okay. Now what is the time?
The time is 3 seconds.
Yeah, 3 seconds. Okay, now you have all the 3 variables you need to solve for the acceleration. So just pop that in your calculator and tell me what you get. And tell me the answer to the nearest significant to improper significant digits, where it is 3.0 seconds now. I changed it. Okay, so tell me the answer when you get it. All right, so this shouldn't take that long. So what would you get?
I got -5.
-5. Interesting. Okay, so your our so my question was, my bad. So the your VF corresponds here, so 15 meters per second. All right, subtracted by 0 meters per second because this is the initial. I think you mixed up the two up. All right, I didn't write it in order VF VIT. I wrote it VI first, then VF then T. All over 3 seconds, 3.0 seconds. So this gives you 5 meters per second. And the answer that we got is positive, right?
Yeah.
So what would the direction be?
North.
North, okay. And then is this proper significant digits?
Yes.
Okay, it's not because here's 2 and here's also 2. So we need to convert it into 2 significant digits. So what should we add?
0.0.
Yeah. Okay. Be more confident in your answers because most of the times you're right. So 5.0 meters per second squared, not second, north. Okay. So I should remind you, like, get in the habit of saying your things with units in them, because like most teachers mark things wrong if there's no units. Because it's like in physics, like we're taking measurements, so we need units, so we need to know what we're measuring. So that's the acceleration. So these are acceleration type problems. Okay. So the break is gonna end in less than a minute. I mean, the break's gonna start in less than a minute. So I'm gonna stop screen sharing. Rachel, you can stop the recording. Okay. Okay. So welcome back. This is the second half of the lesson. So the first thing we're gonna do is another acceleration problem. This one does have a little twist on it, and you're gonna guide me through this problem. So that means I'm only gonna write the things that you tell me to write, and then after I'll tell you if your thing is right or wrong. Okay. Hopefully this worked pretty well. Also, in the first problem, I spelled acceleration wrong. My bad. Okay, so an object traveling south at 20 meters per second. Ends up traveling 40 meters per second north in 10 seconds. What is the object's acceleration? Okay, so this is a pretty straightforward issue. There's just a little twist, which will really help you understand the concept of acceleration, which I'll explain in a bit. Okay, so an object traveling south at 20 meters per second ends up traveling 40 meters per second north in 10 seconds. What is the object's acceleration? Wow, I cannot type today. This is so interesting. All right, so guide me through this problem. What is the first step I do?
Alright, so first the initial velocity is 20 meter per second south, so it's negative.
And then
And then the
So define your direction first. North, south, plus, minus. Just do something like this before you do the question, okay?
Okay.
All right, what's next?
And then the final velocity is 40 meters per second, and it's north, so it's positive.
Mm-hmm. And then what's next?
And so we're going to use the 40 meters per second north.
Okay, wait, you haven't set your variables to find acceleration yet. This is the formula. What other information are you missing?
Oh, the time
Yeah,
is
which is
10 seconds.
okay. And then how would you go about finding it?
Alright, so we're going to use the final velocity, which is 40 meter per second.
Okay, what's the formula first?
Of final velocity divided by minus initial velocity divided by time.
Okay.
Okay, so it'll be 40 meter per second minus negative 20 meter per second.
Okay.
Divided by 10 seconds.
Okay, which is
which is going to be 6 meters per second north.
this is your final acceleration. Okay, so let's see what we need for all the final answers. So we need well, first we need a number that's in the correct significant digits. So is this the correct significant digits? Is 6 the right significant? So what would it be in correct significant digits?
6.0.
Yes, it's 1.0. Okay, now we need to look at the units. Are these the right units for acceleration?
Oh no, per second squared.
Meters per second squared.
Per second squared.
And this is the right direction?
Yes.
Yes. Okay, because it is positive. So this is your final answer. Okay, so that was okay. But you always need to remember in the end, you have to look out for units. So I'm going to write them out here. Units. Oh, my computer's so slow. What is wrong? Significant digits. And that's mainly it. But I usually always try and like make sure the direction is correct. So, oh, this is so slow. Okay, which is the sine. Yeah, okay, let me just close some tabs. Okay.
Nice wallpaper thing.
What wallpaper?
I don't know. What was that?
Netflix.
Okay.
Oh, okay. Okay, so this is all the things I would look for. Okay.
Alright.
Okay, so what does a positive acceleration mean versus a negative acceleration? Okay, so this is a concept. I didn't write it in the notes, but I was going to explain it in class. Okay. So, first of all, acceleration is basically a measurement to tell you if something is getting faster or slower, right? So if you're running at a super, super fast rate, you are accelerating. But if you start running really, really fast and then at a point you get tired and then you walk back down and you stop walking, you're decelerating. So acceleration, all right, is faster. All right. And then if you're decelerating, all right, you are slower. Okay, so I have a feeling that the reason why it's so slow is because on this one whiteboard, I have like so many things. So I'll fix it for next time. I might even start a new whiteboard later, but just deal with this for today. Okay. I mean, just so faster means it means that your speed is getting, your velocity is getting greater over time. Okay. So if it's getting greater over time, right? That means, let me rephrase my words. Hold on. Okay, so if it's getting faster over time, it means that your speed is moving away from zero. Okay, so your speed is basically moving away from zero. Okay, wait. Maybe I should explain this during the graphing section, but I'll, yo, Rachel, I'm low-key stuck here. Wait, I'm choking right now.
Wait.
Wait,
Wait.
I'm choking right now. What I want to say is that if your acceleration and your speed are in the same direction, you're getting faster. But if it's in opposite directions, you're getting slower. But I don't know how to say that in like simple terms. Like, do you know a way how to say that?
Okay. Oh, so just accelerate. You can see that he wrote on the board acceleration and deceleration. So let me think, bro.
Okay, well, the graphing part will
Draw. Do a visual
draw.
drawing. So
Okay.
arrows,
So, okay.
and then I'll just add on or something.
Yeah, okay. So let's say a person's speed is going 1, 2, 3, 4, 5. Okay.
So they're increasing in meters per second. So 1 meter per
Yeah.
second.
1 meters per second squared. So acceleration is 1 meters per second squared. The speed is going faster by 1 each time. Okay. So now let's say that the person is doing 5, 4, 3, 2, and 1. Okay. This means they'll have a negative 1 meter per second squared because they are decreasing by 1 speed each time. Okay. So seeing that this is here and this is this, right? People are tempted to think that this means that an object is going like to the okay, like the person's going to the right, okay? But people are tempted to think that in here the person's going to the right, and in here the person is going to the left. But that's not true, okay? All a negative acceleration means is that an object is getting slower. Okay. Assuming that the direction they're going is positive, a negative acceleration just means that they're going slower. It does not mean that they turned around and started accelerating. Okay.
As
So
in,
this means,
they might not have gone in the opposite direction. They can still be going in
yeah,
the same direction, but decelerating. So having a negative acceleration.
yeah, in the positive direction.
Okay.
So the conclusion is that if velocity and acceleration are going in the same direction, the person will go faster. If the velocity and the acceleration are in different directions, the person is going to slow down. Okay? But it does not mean a different direction. Okay?
Okay.
So another confusing aspect, right, might be this. So what if a person is traveling left? Right? If they're traveling left, and I define right as positive, right? But every time they go to they're moving faster and faster as they're going to the left, right? So if the left is defined as negative, right, then so let's define, okay, so the left is negative, okay? So this means -2 turns to -3 and -4 and -5. So that means acceleration will be -1 meter per second squared, okay?
Okay.
All right, so now this person is going slow again because so he's tired, he's going slow again. So now the -5 goes to -4 to -3 to -2 to -1. All right. So in this sequence of events where he goes from -1 to -5, what is his acceleration? in this series of events? Okay, I'll just say it. There's no need for it to be like this, but it's just -1 meters per second squared. The speed is becoming more and more, the velocity, sorry, is becoming more and more negative, and it's by -1 each time. Okay? So then for here, the speed from -5 to -4 is adding 1 each time. So it's 1 meter per second squared. Okay? So now, given the context that this person's going left, and this is his acceleration, right? You can tell that, well, these are both negatives. So this means that so in this sequence, the person is going faster. The velocity and acceleration are in the same direction. This person is going faster in this term, in this series. Now, in this series, here's a positive sign and here's a negative sign. So if the acceleration and the velocity, or like the way he's traveling and his acceleration, are opposite directions, the person is slowing down. Okay? So the conclusion that this gives you is that a positive does not mean going faster, nor does a negative mean it's going slower. It all depends on the direction. So acceleration plus plus, minus minus, deceleration is plus minus, and minus plus. So if they're opposite, it's going slower. If they're the same, it's going faster. And it depends on the context you're talking about. Okay? Based on the direction defined in the question and the velocities you have, you can find the acceleration, which will then determine if the object is going faster or slower. Does that make sense?
Yeah.
All right. So when you're graphing this, it'll make more sense. And we're actually going to move on graphing right now. Oh, that was a huge mistake. Okay. All right. So let's look at some graphs. Where are my graphs? They're all here. Okay, nice. All right. So the displacement time graph. The displacement at certain periods of time that an object travels. All right, so you know how to read a graph, right?
Yeah.
All right, then we should be doing quite good. Okay, so at 4 seconds, right? This is in seconds, this is in meters. So at 4 seconds, an object travels 4 meters, right? So what does this tell you about the speed from here to here?
It increased.
No, I'm asking, like, what is the speed? Like, what is a numerical value of the speed?
Is that, sorry, like, is that number
Which number?
the number, like, it stopped on, is that 9?
This is a 4.
Oh.
Okay, so my question was, all right, I'm going a bit too fast, maybe, possibly. All right. So let's look at this. Let's look at this graph, okay? So an object, right, is in the first 4 seconds of its journey, it travels 4 meters from its original position. All right. Then another 4 seconds passed, and it's still at 4 meters from the position that it was 4 seconds ago. Then another 4 seconds come back, and the object travels back to where it originally was because it's at 0. Okay, 4 more seconds pass by, and now it's 2 meters a negative direction away from where it originally was. Then another 4 seconds later. Wait, the audio stopped? Rachel, did the audio stop?
Let me pause recording.
All right. So, first we have to recognize a few things about this displacement time graph. Okay, so first we're going to recognize that, well, it's all made out of diagonal lines and straight lines. Okay, so why is it so important for a diagonal versus diagonal and straight lines? It is because a diagonal line on a displacement time graph, right, this represents uniform motion. Do you remember what uniform motion is?
It is
It is what is it?
so basically it was the so like
All right. Okay, so uniform motion is essentially a constant speed / velocity in the same direction. An object traveling at the same speed or velocity in the same direction in a straight line. So it's like the simplest form of motion ever. It's just like you walk from here to there and you don't get faster or slower and you look in the same way. Okay, that's a uniform motion. So if a straight line means uniform motion, right, then that means there are uniform motion formulas that we have already learned, which is distance equals speed over time, speed over distance over time, and the time one doesn't matter because we didn't be given the time. And these work for velocity as well because we are working with vector quantities. All right, so knowing the information that you have now, what do you think the speed of this little section would be? An object that travels 4 meters in 4 seconds. What would the velocity of this section of travel be in the first 4 seconds, given what you just learned? What do you think it would be? Here, talk to me. Guide me through what do you think it would be.
it will be so it would be
What will it be? Given that you know these two formulas and you know how much they walked in a certain amount of time, what would the speed be, velocity be for this section? Okay, so this is like an interactive question. So you're supposed to like communicate what you think it would be. So what do you think it would be? And what formula do you think we should use to find it?
I think the formula would be the
So the formula is right there on the screen. It's V equals D over T. Okay, so you have D, 4, you have T, 4. 4 over 4 is 1. Okay, so the velocity. So right now I'm teaching you how to convert from a displacement time graph to a velocity time graph, which will then can be converted to an acceleration time graph. So it's best you stay with me so we can get through this lesson. Okay, so 4 over 4 is 1, right? So remind me what uniform motion means again. Could you please remind me what uniform motion means?
it was the so like so basically when something is traveling in like equal distances in equal intervals of time.
What?
She's right. That's one way to explain it. The easy
Yeah, it's
way to
one
say
way.
it is just speed. It's the same speed, constant.
Yeah,
That's all. It's
like through its travel, through an object's travel, the speed stays the same the entire time. Okay? It's like if you set a treadmill to a certain speed and you just run at it for like 30 minutes, you are experiencing uniform motion. Okay?
All right.
All right. So if the speed is constant throughout the entire 4 seconds on the velocity time graph, this would mean that the speed at 1 would stay for the entire 4 seconds. So we would draw a line like here, a straight horizontal line right here. Okay? Because it's 1 meter. We've discovered that it's 1 meters per second using this formula that was written right here. We have determined that the speed is 1 meters, the velocity, sorry, is 1 meters per second throughout the entire 4 seconds. So that means it will stay like this. Okay?
All right.
Okay, so now let's move on to the second part of travel. During the 4 to 8 second period, the object's displacement remains at 4 seconds the entire time. Right? So what does this tell us about the object? What state of motion is it going through? Like what's happening to the object? There's no state of just what's happening to the object during these 4 seconds.
It's not increasing its speed, so
It's not increasing its. Remember, we are given the distance time graph, not the speed time graph. It's not increasing its distance. If it's not increasing or decreasing its distance, what is happening to the object?
it's staying at one spot.
Yeah, it's in one spot. So that means it is not moving, right?
Yeah.
So when the object is not moving, what speed is it at?
0.
0. Okay. And on the velocity time graph, how do we represent that it is staying 0 throughout the entire 4 seconds? So in here, we represented that it was 1 second throughout the whole thing by drawing a horizontal line throughout the entire 4 seconds. So if the speed is 0 for the whole 4 seconds, how should we represent it on this graph?
Would it move down to like the 0 point, like the?
So it would be a horizontal line on the 0 from 4 to 8. Is that what you're trying to say?
Oh, yeah.
Okay. Wow. Okay. So now it is 8 to 12. Okay. Now let's see what this is doing. So from here to here, the object travels back to its original position from a position of 4 meters north. Okay. This is north, this is south. So once again, we have a diagonal line, so it's in uniform motion. So how do we show what speed this is going throughout the 4 seconds? What formula do we use? It is the formula that we use for the first section, and it has a green box around it, and it will be used for all the questions. What is the formula?
So the velocity equals displacement over time.
Yeah, okay, good. Okay, so what is the displacement of this action here? What would the displacement be? Okay, we might need to speed up the lesson, so I'm gonna use the other student as a utility, so this process goes smoother.
I'll repeat your question. I was thinking of answering your
Okay. Okay, so Rachel, what would the displacement be from 8 to 12 seconds?
8 to 12 seconds. Okay. So the displacement.
Yeah. what would displacement be? Because right now, like I'm gonna make the connection on what
Oh,
goes from here to here, like after doing like a raw calculation.
okay, so wait. From 8 to 12 seconds, the change in displacement. Well, at 8 seconds, they started at 9 meters north.
This
And
is
then
four.
at
This is
12,
four. This is
oh, it's
four.
4. Oh my God.
Yeah.
4 meters north. And then at 12, they ended up at 0. So in total, they walked a displacement of 4 meters.
Yeah, 4 meters south. You're north. You come back to where you are. You have to go the opposite direction, so it's south. Okay.
4
All
meters.
right.
So if let's say you get stuck on this question, which you shouldn't get stuck on, but in the case you do get stuck on, um, displacement final minus displacement initial is also displacement. All right, but this formula is not really like common, but it is like it is taught sometimes. Like I was in summer school and they said that they can use this formula. So final, you're at 0. Initial, you were at 4. You had -4, so that means 4 meters south. Okay.
All right.
So now using which formula? So now using the formula that is box and green that I've asked for 3 times. What is the velocity of this of the travel from 8 to 12 seconds?
Um. It is.
What would it be? What would it be? So -4 meters divided by 4 seconds is -1 meters per second. So on a graph, it would be represented here. And because the speed is constant, it is a horizontal line that goes over the time period. Okay?
All right.
Okay. So try to stay with me. So like
2010.
when I ask, like be a open person, don't stay like quiet because it doesn't help both of us. All right. So now let's observe 16 seconds, right? This object, huh?
5 o'clock.
5 o'clock.
5:01.
All right. So we're done here, right?
I